Hey everyone, we're going to continue with chapter 6. We left off last lesson with section 6.2, which was just reviewing the difference between a discrete versus a continuous random variable. And I feel like we're comfortable with that. We did cover that in chapter 2, so this was just a quick review reminder. And what I had said in the last lesson is that in this chapter, we're only going to work with discrete random variables. And specifically, I'm going to teach you about probability distributions of a discrete random variable. So what is a probability distribution? A probability distribution is a distribution which displays the probabilities associated with all the possible values of a random variable, specifically a discrete random variable. So really all it is a table, and it has two columns. It lists the values of X for a random variable, and then in the column next to it, it displays the probabilities associated with all those possible values for X. So here's an example of a discrete probability distribution. The table below is a probability distribution for the random variable X, which represents the number of hits a baseball player gets in a game. So let's make this a little bit bigger. So this first column represents the values of our discrete random variable, which is the number of hits a baseball player gets in a game, which is discrete, right? We could count the number of hits. So it's possible that a player gets 0, 1, 2, 3, 4, or 5 hits. So these are all the possible values of X in this instance. There's 6 of them. And then next to it, we have a column for P of X, the probability of X. So this 0.17 represents the probability that X is equal to 0, meaning that the player gets no hits in a game. So there's about a 17% chance, or the probability is 0.17. There's a 34% chance, or a probability of 0.34, that a baseball player will get 1 hit in a game, and so on and so forth. So that's how we read and interpret a discrete probability distribution. Really think of it as a table with 2 columns. The first column being X, which is a list of all the possible values of the random variable X. And then the second column is the probability of each one of those possible values of the random variable. Now, before we move on, I want to point out 2 very important characteristics that must exist in order to have a valid probability distribution. So this is really important down here, characteristics of a probability distribution of a discrete random variable. So the first characteristic is that the probability associated with a particular value of a discrete random variable in a probability distribution, it always has to be a number between 0 and 1 inclusive. So what that's saying is that each one of these probability values has to be between 0 and 1 inclusive. And this goes back to what we discussed in chapter 5, that a probability always has to be between 0 and 1. You can't have a negative probability, and you can't have a probability greater than 1 because it doesn't make sense. So that property or characteristic is satisfied here, because if you look at all these probabilities in this table, they're all between 0 and 1. The other really important characteristic is that the sum of all the probabilities in the probability distribution must always equal 1. So in other words, when we sum up this column for the probabilities, it has to add up to 1, or else it's not a valid probability distribution. Now, if you were to add up these values, 0.17, 0.34, 0.28, 0.15, 0.04, and 0.02, they sum to 1. So the other criteria, so here's the first criteria that needs to be satisfied. The second is that the sum of all the probabilities in this discrete distribution has to add up to 1. So those 2 must be satisfied in order to have a probability distribution. So let's practice keeping in mind those characteristics. So let's look at example 3. So it says, given the table of probabilities for the random variable x, does this form a probability distribution? Answer yes or no. So remember, it has to satisfy these two characteristics. The first one is that all the probabilities have to be between 0 and 1. So we'll write this down again over here. So P of x has to be between 0 and 1. And the sum of all the probabilities has to add up to 1. But I see right away that this table does not represent a probability distribution because it doesn't satisfy that first characteristic, right? Negative 0.30 is not a valid probability. So no, this is not a probability distribution since the probability of x cannot equal a negative number. It doesn't make any sense. So even though if we were to add up all those probabilities, they do add up to 1, it doesn't matter. The first characteristic is not satisfied. So this is not a probability distribution. So let's look at the second one. Does this example form a probability distribution? Answer yes or no. So let's check. So all these probabilities, they are between 0 and 1 inclusive. I don't have any negative probabilities here. I don't have any probabilities that are bigger than 1. So my first characteristic is satisfied. So P of x is between 0 and 1. Now we just have to make sure that when we sum up all the probabilities that they add up to 1. So if I were to add up 0.02 plus 0.07 plus 0.22 plus 0.27 plus 0.42, they do add up to 1. And you guys could check that yourself on the calculator. But 0.02 plus 0.07 plus 0.22 plus 0.27 plus 0.42 does equal 1. Therefore, both characteristics of a probability distribution are satisfied. So yes, this table would represent a discrete probability distribution. We can also use probability distributions to answer questions. So let's look at example 4. Example 4 says, consider the following discrete probability distribution. Find the probability that x equals 5. So you'll see the possible values of x in this case are 2, 5, 6, and 8. And we know the probability that x is 2 is 0.16. The probability that x is 6 is 0.3. And the probability that x is 8 is 0.21. But the probability of x equals 5 is missing. Think for a minute how we could get that missing probability. And if you thought, all right, the probabilities in a discrete probability distribution have to add up to 1, you're right. You could use that property, right? So we know these should total 1. So remember, the sum of all the probabilities should equal 1. So if I take 1 and I subtract 0.16, 0.3, and 0.21, whatever's left over is going to be that question mark, right? And that works out to be 0.33. So the probability that x equals 5 is 0.33. So let's answer the next question. So example 5. So again, I gave you a discrete probability distribution, and this really I just want to practice finding probabilities. So let's find the probability that x is greater than 3. And just a quick reminder, this is greater than, and then this guy is less than. So we want to find the probability that x is greater than 3. So x is equal to either 1, 2, 3, 4, or 5. But we want to know what's the probability that x is greater than 3. Well, what values of X in this table are greater than 3? Only 4 and 5. So what we have to do is we have to add up those probabilities. So that's going to be equal to the probability that X is 4 plus the probability that X is 5. So that's going to be 0.3 plus 0.2, which is 0.5. Let's look at the next one. Consider the given discrete probability distribution. Find the probability that X is less than 2 or X is greater than 3. So why don't we circle what values satisfy this probability statement, right? So when is X less than 2? X is less than 2 when it's equal to 1, right? Or it could also be greater than 3. Well, when is X greater than 3? When it's 4 or 5. So the answer to this is going to be the probability that X equals 1 plus the probability that X equals 4 plus the probability that X equals 5, because those satisfy X being less than 2 or X being greater than 3. So we're going to take 0.1 plus 0.3 plus 0.2, and we're going to get 0.6. So we're going to end this lesson here. And in the next lesson, I'll quickly go over how to construct a probability histogram, and then we'll work on example 6.